One last lecture in our Air 3 learning target. This time we're going to learn about pressure and temperature. And just like pressure and volume, pressure and temperature are directly related. So you should be able to quickly look ahead and write down on the sheet there, if temperature increases, what happens to the pressure? You should have written down that pressure increases as well. So if they're directly related, just like our temperature and volume, if the temperature decreases, then pressure is going to decrease. So why would that be? What does temperature do to those particles? Temperature is going to affect that kinetic energy. The more kinetic energy, or the energy of movement, means we have more collisions. Those increased collisions cause more pressure. So that pressure is going to then be increasing on the sides of the containers. So quick video to summarize everything on Gay-Lussac's law. So in that video, you would have witnessed that as that temperature increases, you would have watched that gauge on the side here and watched that pressure increase as well. So two things must be true if we are working with Gay-Lussac's law. The first one is that the volume must be held constant. So just like when we learned about temperature and volume, the pressure was constant. This time, the volume is held constant. The second thing is our temperature must always be in Kelvin. On the bottom of your sheet, what I want you to do is I want you to draw a picture that represents this law along with two real-world examples. If you're struggling and having a hard time coming up with two examples, go to Google and type in examples of Gay-Lussac's law or examples of pressure and temperature relationships. That's it for Learning Target 3.